Hello and welcome to Lesson 8-6. Today we're going to look at geometric sequences. If you recall, a while back we talked about something called arithmetic sequences. An arithmetic sequence is when the difference between two terms, okay, so it could be the difference in between like the first and the second, or the second and the third, or the third and the fourth, or the 99th and the 100th, there was a common difference, meaning that you could subtract two numbers and as long as they were consecutive, you would get the exact same number. Okay, so that was an arithmetic sequence. Today we're going to look at a geometric sequence, and a geometric sequence has a common ratio. Because if you notice, 10 minus 2, that would be 8. 50 minus 10 is 40, so that's not a common difference. But if I go 10 divided by 2, that's 5. 50 divided by 10 is 5. 250 divided by 50, that's 5. This is what we call a geometric sequence. So the ratio of consecutive terms is constant in a geometric sequence, just like we showed you, and it's what we call the common ratio. A lot of times it is shown with the lowercase r. And essentially what that means is we can multiply by the same number or this r value to get each term. So if I took 2 and I multiplied it by 5, I would get 10. If I take 10 and I multiply it by 5, I'd get 50. 50 times 5 is 250. So we could actually say that the fifth term then, if I wanted to, we could predict that or know that if I take 250 and I multiply that by 5, we're going to get 1,250. And we can continue to do this pattern forever, essentially. So the key thing is you have to know how to find that common ratio, okay? And again, we're just going to divide consecutive terms. So we would take the second term, divide it by the first. So I could go 10 divided by 2. I could do the third term divided by the second. So I could go 50 divided by 10. I could go 250 divided by 50. All of these are going to give me that common ratio of 5. So for example 1, what we're going to do is we are going to look for the common ratio. So to begin with for number 1, I'm just going to take two consecutive terms. So I'm going to start out with 12 divided by 3. And I can see that I get a common ratio of 4. And again, you could have done 192 divided by 48, and you should have also gotten 4. But our common ratio here is 4. For number 2, I'm going to do the first and the second terms. So I'm going to go 20 divided by 80. Well, 20 divided by 80 is going to give me 1/4. So my common ratio here is 1/4. For number 23, I'm going to use the third and the fourth term, and I have negative 24 divided by negative 12, which will give me 2. So again, it doesn't matter which terms you use, they just have to be consecutive. Now for example 2, we want to find the next 3 terms. So in order to find the next 3 terms, we first have to find our r value. So r can be found by taking the two consecutive terms, and in this case I'm just going to go negative 60 divided by 120, or I get a negative 1/2. So to find the next 3 terms, I'm going to multiply the previous term. So in this case, a negative 15 times a negative 1/2, well, that's going to give me a positive 7.5. And then if I take a positive 7.5 and multiply it by my r value, I'm going to get a negative 3.75. And if I take a negative 3.75 and multiply it by a negative 1/2, I end up with a positive 1.875. So these right here are my next 3 terms. For number 2, my common ratio is going to be 8.8, and I'm just going to take the last 2 terms just for something different, divided by 4.4, so I can see that my common ratio is 2. And if I want to find my next term, I'm going to go 8.8, and I'm going to multiply that by 2, and I get 17.6. And if I take 17.6 and I multiply that by 2, I get 35.2. And if I take 35.2 and I multiply that by 2, I get 70.4. So these here are my next three terms. And finally, for number 3, I'm going to take, again, we'll take my last two terms. Fractions don't scare me. So I'm going to take 3/8 and I'm going to divide that by 3/4. Well, if you remember, 3/8 divided by 3/4 is really the same thing as taking 3/8 and multiplying it by 4/3. So I can see that that's going to give me a common ratio of 1/2. So if I take 3/8 and multiply it by 1/2, I end up with 3/16. And if I take 3/16 and I multiply that by 1/2, I get 3/32. And 3/32 times 1/2 will give me 3/64. So these here are my next three terms for part 3. Now for example 3, we have to determine whether the sequence is arithmetic or geometric. So, and you can really take whichever approach you'd like to, okay, but I'm going to look at my first two terms here, and I see that -5 minus a -7 is going to give me a +2. If I do that with these next two terms, -3 minus a -5, that's also going to give me a +2, and I'm just going to double check. -1 minus -3 is also a +2, so this right here is going to be arithmetic, and the common difference is 2. Now if I go and I do the same thing for number 2, I get 28 minus 56. Well, that's going to give me 28, but right away I can see that 14 minus 28 is not going to give me a -28, it's going to give me a -14. So I know that that's not going to be a common difference, so I'm going to look at ratios, and I'm going to say 28 divided by 56 is going to give me 1/2. And I'm just going to double check. 14 divided by 28 is a half, and 7 divided by 14 is also a half. So this is geometric, and R then is equal to 1/2. Likewise for the bottom, this one, it looks like I go 2, 4, 6. So if I go 4 divided by 2, that's going to give me 2. But 6 divided by 4, that's going to give me 3/2. So that's not right. So I'm going to check for common differences. So 4 minus 2 is 2, 6 minus 4 is 2, 8 minus 6 is 2. So this is arithmetic, and my common difference is 2. And then finally for number 4, this one right away I kind of notice I go 2, 4, 8, 16, so it looks like I'm doubling everything. So I'm just going to double check that if 4 divided by 2 is 2, 8 divided by 4 is 2, 16 divided by 8 is 2. So this is geometric, and your R value is 2. So now that we know how to find the common ratio, what we're going to do is we're going to learn how to write a rule for a geometric sequence. So, and what this rule is going to allow us to do is, let's say I want to find the 100th term. Okay, I'm going to be able to plug in 100 for the n value in this equation here, and I'm going to be able to find that number right away once I know what the geometric sequence is, because I don't want to have to sit there and find out the first 99 terms in order to find the 100th. So this is kind of like a shortcut for that. So to find the geometric sequence, we have a sub n. So this is just the nth term. So again, if I wanted, let's say I wanted to find the 100th term, I could say a of 100, and that means the 100th term. Okay, so to find the geometric sequence, this is the nth term, and then it says take your first term a. So if I look at this up here, and actually I'll just do this example. So my first term is going to be this number here. So I would say that a of n equals 2 times my R value, which I have to find. So if I go 18 divided by 6, that's going to give me 3. So my common ratio is going to be 3. And then notice it says that you just raise it to the power of n minus 1. So this right here is my geometric sequence for the numbers 2, 6, 18, 54, and so on. Now let's take a look at a few actual examples. So for example 4, it says find the first, 6th, and 12th terms of each sequence. So we're going to work out part A first. So if I want to find the first term, I'm literally finding A of 1. So that means I'm going to plug a 1 in for every n. So that means I have 4 times 3 to the 1 minus 1, which is really 4 times 3 to the power of 0. 3 to the power of 0 is always 1, so that tells me that my first term then is 1. Or sorry, 4, because I have 4 times 1 is 4. If I want to find my 6th term, I really have A of 6, and that's going to give me 4 times 3 to the 6 minus 1, which gives me 4 times 3 to the 5th. Well, I really have 4 times 3 to the 5th is 243. So if I multiply that by 4, I get 972. And then the 12th term, I have A of 12, and this is going to give me 4 times 3 to the 12 minus 1, which is the 11th. So I have 4 times 3 to the 11th, and if you type that in, you're going to get 708,588, and that would be your 12th term. Likewise, for part B, I have A of 1 is going to be negative 2 times 5 to the 1 minus 1, which is really 0. So this whole thing is going to go to 1. So that's going to tell me that my first term is just a negative 2. For my 6th term, I really have negative 2 times 5 to the 6 minus 1, which is negative 2 times 5 to the 5th, which is going to give me a negative 6,250. And then my final term is A to the, or the 12th term, or A of 12, is going to be negative 2 times 5 to the 12 minus 1, which is negative 2 times 5 to the 11th, or I get a negative 656,250, and that would be my 12th term. And my last example for today says that you drop a rubber ball from a height of 1 meter and it bounces back to lower and lower heights. Each curved path has 80% of the height of the previous path. Write a rule for the height of each successive path, and then we want to find the height of the ball reach at the top of its 5th path. Now, we do have a diagram that's been drawn, so it shows you dropping the ball the first time, then it's going to go up 80% of this on the second, and then 80% of the second on the third, 80% on the fourth, and it's so on. Okay? So, now some key things that we were told, okay, is that we have 1 meter, okay, and I'm actually going to convert that over into centimeters, okay? And if we think of our formula here, we have A of n equals A times r to the n minus 1. So what I'm going to do is I'm going to call my lowercase a that 1 meter, and that's given right here. And I know that my r value, it says it's 80% of the height. So my r value then is going to be 80% of 1 meter, or 0.8. So now that I know my r value and I know my a value, I know that my generic equation is going to be a of n equals 1 meter times 0.8 to the n minus 1. So this is my equation that I'm going to be using here. Now for my fifth term, because it says write a rule for the height, which we've done, what height will the ball reach at the top of the fifth path? So that really means that we are looking for a of 5. So that means I have 1 times 0.8 to the 5 minus 1, or 1 times 0.8 to the 4th power. And if you type that in your calculator, you're going to see that you get 0.4096, and your units on that would be meters. Now if you want to do a quick conversion, okay, 0.496 meters is really 40.96 centimeters. So maybe that gives you a little better understanding. Please let me know if you have any questions. Otherwise, I hope you guys have a great day, and I will see you in class.